Okay, so for this question here, it's asking how many 7-digit even numbers less than 3 million can be formed using all the digits 1, 2, 2, 3, 5, 5, 6. So the numbers that are formed need to be less than 3 million, but they also need to be even. So even restricts me in some of my choices. Even means the number has to end in 2 or 6. Okay? If it's an even number, it can end in 3, it can end in 5, and it can end in 1. Okay? Also, less than 3 million means that the numbers have to start with 1 or 2. Okay? So that gives me, and it really starts narrowing things down now, and we need to consider the different cases that we have here for this. Okay? So even numbers got to end in 2 or 6. Okay? And then less than 3 million means that the numbers have to start with 1 or 2. You can't have it any other way. So if we start off with case 1, okay, so let's say we have 1, that's the first digit. Okay, so 1 is the first digit. And then last digit is 2. There is no other way to do this. There's a quicker way. You just have to consider the cases. And we're going to be doing a lot of that and considering different situations. Okay, so 1 as the first digit. Let me just put there like that. Okay, and last digit is 2. So when that happens, if we have 1 in the first position, and we're going to have, we only have one choice for the first and the last positions right now, okay? So really there's either a 2 back there or there's a 1 there, okay? If there's 1, 2 in here, then there's going to be 1, 2 in there, okay, in the middle of all of this. But this is going to be multiplying again. And really what we have in the middle now is we've got 5 numbers left over. So 5 factorial divided by whatever we have doubles of. In this case, the 2 factorial represents, this is the 2 5s. Okay? So we've still got 7 numbers. Alright, we're starting with 1. We're starting with 2. This would be the number 1 in here. Okay? This is the number 2 in here. Okay? Then what's left in the middle? We have the other 2, right? The 3, the 5, the 5, and the 6. Okay? And this gives us a total of 60. Okay? If you want to stop it here, you can stop it here. And you can try case 2. What I did with case 2 is let the first digit, I'll set it up and then you can try it. So here's case 2. And we're going to say first digit is 1. Okay. And the last digit is 6. Okay, first digit is 1, last digit is 6. So when we think of the different ways, you can pause it now and you try it on your own, okay? But I'm going to continue on if you don't pause it. So to put the 1 in the first spot, there's really only one way. It's the number 1. And then over here we have the 6, and there's really only one way to do that as well, okay, to put that in there. And then we have times and times again. Alright, we've still got 5 numbers in total, but now the identical items that we have in there, okay, we've got, since we're using the 1 and the 6, we have 2 2s that we need to divide out, and the 2 5s that we need to divide out. And this gives us a total of 60. Oops, sorry. I'm looking at the wrong part there. Gives me a total of 30. Okay, so we did 1 and 2 at the end, and we did 1 and 6 at the end, and now we'll take a look at ending with 2, starting with 2 and ending with 2, and then starting with 2 and ending with 6. Okay, and those are really our 4 cases that we have. Okay, so for case 3, first digit is 2, and last digit is also 2. Okay, so again, one way to get that 2 in there, one way to get the 2 in here, it's only one spot that we're filling, times and times again. Okay, now since we're using both the 2's, we have 1, 3, 5, 5, and 6 left over. So we've got 5 numbers to choose from, 5 digits, but 2 are identical. So actually we get the same as before as the first one, and that's 60 different ways we can do that one. Okay, the last case, and again, if you want to try these before I show you, just pause it. So first digit is 2, last digit is 6. Okay, so again for the first digit, 1, and that's the number 2 there, times and times, and one way to get that number 6 in here. Okay, so what's left in the middle now? We used the 2 and the 6 in this case, so we have a 1, a 2, a 3, and 2 5s. So again, 5 factorial divided by 2 factorial. And here you can see it's a nice example between when do we multiply, when do we add. Okay, and you can see how that works here, because all of these cases are individual cases, and they're happening at the same time. So case 1 is happening, we're multiplying everything in there. Case 2 is happening, we're multiplying those. Case 3, and then case 4 at the end. Okay? And we're multiplying everything that's in there. However, when we look at the total number here, because each one of these, you can't have these happening at the same time. They're all distinct, they're all in mutually exclusive events. So now, the total number is equal to, we're going to add everything together here. Okay, so 60 plus 30 plus 60 plus 60 is equal to 210 different numbers that we can get from there. Okay, and that's how you need to do it case by case in this particular question here. Okay, so that's 1.4. Guys, the test is until Friday. I'll be back tomorrow. We'll have tomorrow, Wednesday, and Thursday to really go over things, tighten things up a lot before we have the test on Friday. Okay? So try the homework for 1.4. You can review the videos over and over again if you need to, and they'll be posted there. All right? We'll see you tomorrow.